All right, so this is the KSUG Meetup Kubernetes user group, and we run every month the session. Okay, similar place either in this office or the Google office in the perimeter. So we actually switch between two providers. So my name is Faisal. I'm one of the volunteers. I work in Amazon. I mostly cover the real estate and drinks. So KSUG is basically a community, guys. It's a community that we help each other to learn about Kubernetes, to learn about cloud computing, and we help each other to be successful. It's about educating. It's about supporting each other to learn the Kubernetes way as you go. So you can see here we have community worldwide. We have people in APJ. We have EMEA community. We have North America community. So we have over 1,000 plus nerds. We are also on the LinkedIn, so feel free to scan the QR code, join our LinkedIn. We promise not to spam you with stuff, but still, right? So join. That's about the community. Let's go to the next one. Okay, so as I mentioned, we do Meetup every month. We do in Melbourne, we do in Sydney, we have in Singapore, we have in India, we have people in India, we have multiple cities available. So please feel free to share it with your friend to join our meetups. And we are happy for you if you want to present something interesting relative to Kubernetes, relative to cloud computing, relative to AI. Please reach out to us and we'll make sure it happens as you go. So today is supported by AWS and JR Academy. So we have volunteers helping us out. So maybe share your hands to see where we are there. So they're there helping us out. All right. At the end, basically take some pictures, upload the pictures on this QR code if you want to, and then you can download also the pictures that we share. So whatever we share here, it will be available in this Microsoft Drive link as we go. So the agenda is as very simple today. I'm doing the introduction. That's the best part of the day, of course. And then we have 4 talks. Okay. The first talk with Melanie. I don't know how to pronounce your Chinese name, Melanie. Sorry. So you can see here she will talk about GenAI Lifecycle. She's a specialist SA in AWS. Then we have a partner, OpenChoreo. Binura will be presenting about standard platform engineers. Then we have Vincent, he's also from AWS. He will be presenting production grade AI agents. And the last but not least, we have Stan. I think Stan is over here. He will be presenting AI resume and cover data optimization, right? So if you're looking for the job, stay for the last session, right? At the end, because generally we do like 2 to 3 sessions. Today we have 4. So quiz time will be gone. There will be no quiz anymore today. But please stay at the end. We're gonna talk, take some group photos. And also we have swag giveaways. So our swags are basically Code Cloud vouchers where you can go and get yourself prepared for certification on Kubernetes. And we have Packet Pub actually sponsor us to send some books. So at the end, you will fill the form and we will pick randomly people who will receive the voucher or the book later on in the meeting, right? So towards the end, we'll have some group photos and feedback session where you help us out. Our mission, I already told you, is to help each other. Nothing paid about here. We're looking for sponsors to help us out for the next session. So if you know somebody or if you want to speak, right? If you want to speak something interesting, reach out to us and we'll be helping us out from there. These are some of we have a program called Kubernetes Astronaut. You can see on the top, KSUG.AI Astronaut. So it's basically people who actually takes all the AWS certification and they become astronauts. So you can see our founder, Yong Kang, is the first one. And then we have 2 programs. One is astronaut, but the other one is Kubestronaut, where actually takes all the Kubernetes certification. So if you pass all these, you'll get this title. And we'll be helping you out to prepare for that using vouchers in the Code Cloud and all. Kubestrong is our community, as I was mentioning. We are available across the globe. And you can see the astronaut plus Kubestronaut equals to Kubestrong. So if you know everything about AWS, if you know everything about Kubernetes, you become a Kubestrong. which is a badge that you have certified. You have too much time to take certification, basically, right? So make sure that you are, if you're interested in that, let us know. These are some of the Cube Strong members who has done all certifications of AWS and Kubernetes, CKA and CKD certifications. This is our link where you can find out the link if you want to use the Zoom link or other important links from KSUG community. Please feel free to find out link.tree/ksug.ai. That's your link where you get all kind of information, all kind of links from our place. We have some certification details, which I think I'm not going to bore with you. These are the two beautiful gentlemen as here. And then we have supported by Code Cloud today. Code Cloud is actually helping us to give you vouchers. You go to their website and you get prepared for certifications, Kubernetes and AWS. And of course, AWS, Amazon is promoting this today by providing a real estate and some part of the drinks. And the remaining part are coming from WSO2 and other sponsors that we have. If you are not the lucky one who actually won the quiz today or by selected for the program, you can use 37% discount on the Code Cloud website. You can go to the website codecloud.com/ksug and use this Code Cloud coupon code or whatever that will give you 37% discount if you want to use your services on everything Code Cloud prepare for you. And today, lucky winner that I mentioned will get 3 free vouchers for 3 Code Cloud vouchers, 3 packet books, and 1 Azure certification book available on the Code Cloud. So we'll give all these 3 today after you fill the form towards the end of the presentation. That's about it. I'll send you this link at the later on to fill the form to give us feedback. Again, we're looking for sponsors. We're looking for speakers and any kind of help us out to help the community, help each other as we grow from here. That's about it. So I'm gonna give to Mel. Mel will join here, and then we will quickly run from there. Okay, we have 4 sessions today, so we're gonna run a very tight schedule. I'm gonna be real master today. So after every 20 minutes, we'll switch on the presenter. Share. Are you able to see? Okay, cool.
Oh, good. Thanks.
Faisal. Yeah, sorry. No worries. So, who are data scientists? Data engineer, ML engineer, AI engineer, engineer. Okay, what's engineer? Okay, no worries. So yeah, the reason I'm asking who are the audience because I want to understand like how familiar you are with the concept we're going to talk about today, and then that you can pick up that. Okay, so but I'll talk a lot. As Faisal mentioned that I only have 20 minutes, so I'll go fast. By the way, if you have time, just take your phone, scan this QR code. We have recently published our Generative AI Lifecycle operating excellence principle guidance, which you can say is a white paper that we published. Faisal and Vincent, we all worked on that piece of work, and today's content is purely based on that. So if you want to deep dive into some concepts or where we don't really have time to deep dive into a specific topic, to be honest, like this deck is about 40 or 50 pages, but I reduced it to 15. So you know that how much I have skipped. So I don't really have I normally don't like to present in front of my laptop, but yeah. Can I put it? Yeah. So as we know, with the start of ChatGPT, everybody started to think about large language model. It becomes the thing because I actually started my master research in computer vision. So that's the time when I actually started using neural network, that like SVM and all this decision tree actually was those kind of basic models. But then the challenge with natural language is always because of the depth or the complexity of the neural network that we could potentially get. So that's why once large language model becomes bigger, more depth, and then the self-attention and transformer architecture becomes to be a component of success, to be able to basically generate human level language, understanding, and generation. It actually came into the role. So that's where the AI booming really started. And now, as we can see, people are starting, because once developers, everybody, all the money also comes into this field, it makes the
faster development and then the scaling of this space, and then people are starting to leverage the capabilities, the power of large language models to start to do things and to explore the areas where it cannot imagine any automation. So that's why, like, how many of you are using deep research? How many of the AI startup companies that you have tried? Have everyone heard about Manus? GKE.AI, those are the Chinese companies, but then you must have heard about Anthropic has deep research, right? You have tried. Google has deep research. AWS also has. What service is that called? Anyone knows? Sweet. That's our recently GA product. It includes deep research, which is pretty cool. So all of those kind of, but then you must be familiar with Cloud Code. Cloud Code, AWS has another product called QCLI, Q1. Have you heard? Basically, coding agent is another kind of booming revolution that we are seeing something impossible. So nowadays, I thought when I used to do EDA with our customer or like workshop with the customer, we're basically coding from scratch, finding all the people that we're putting them together. Nowadays, I don't even code. I just use natural language to prompt either Cloud Code or QCLI, and it will finish the work. So we were able to build some end-to-end agentic workflow POC using aging for runtime, using Lambda, using aging for Lambda plus aging for paper. Aging for service is basically given kind of agentic service. So we have all generative AI. So you can see how much AI is changing our lives. But then when you are actually building a solution, how many of you are thinking about the challenges that you face? How many of you have already built GenAI or agentic AI solutions that put it in production? Your company. So what type of application you're using? Do you want to give an answer? Any agent solutions in production? So what kind of autonomous general? Autonomous present to what? It's general like that. Okay. So like for example, deep research is kind of like agentic workflow. Anyone has heard about our agent for GenAI? Anyone has used the RAG solution in your production system? RAG checkbox, right? So which can pull information from the backend knowledge base and then adding to your prompt to get your LLM generating answers based on grounded facts, basically, right? And have you thought about like when you put something into production? Now we know like Anthropic basically they released Claude 4 in May and Claude 4.5 released in September. Almost half a year. Every half year now you can see the big vendors are releasing new models. Is it easy for you when you have a solution in production and just swap the model ID? Simple as that. Will it work? I see head shaking. That's correct. It won't work because first of all, new models come into new capability. For example, 3.5 doesn't really have extended thinking. Starting from 3.7 or 4, they started extended thinking. And also they're deprecating certain features as well with the new model. And also, when you have guardrails, anyone know guardrails? Like yes. So when you want to block certain things, your model's behavior will change. The guardrails that you put in place in production may unexpectedly block the queries that used to work. So you need to perform extensive testing and verification before you have to make any change in your production. You don't want to break your production workflows unexpectedly just because of model ID change. So these are all the challenges that we face. So the idea that we're thinking of when you're building a solution and putting it in production, everybody always starting with the idea. And then all the companies that I mostly when I speak with, they have all different ideas. They want to use LLM or GenAI this here, there. But then how do you prioritize your project? You cannot really have 100 projects happening at the same time. There will always going to be a priority list, right? We will start with something where we learn, we collect knowledge, experience, and then we scale to more projects, more teams and staff, more confidence. But then how do you prioritize that project? It comes with understanding define your business goal, align with your technical goal, and then starting with verification and also understanding why you need to start with that project and what are the challenges that you may potentially face. And then once you identify the project that you want to build, you start collecting data. When they collecting data, don't think about your functioning model. There's nothing about functioning. That's the main concept. Whenever I say collect data, people say, oh, we don't function model, we don't train the model. I say, even you don't train the model, collecting data sometimes means you need to collect your golden data set to be able to verify what success looks like. Because if you don't really know what success looks like, you just blindly building something and then putting, and I want to run generating output. That is not right. Because now new generative AI powered applications is different from traditional applications because of the indeterminacy it brought by LLM. Hallucination, and then LLM can always respond to you with something, but doesn't mean it always gives you the right answer. But traditional application, what we do, we basically think we always have a deterministic role and generate something out. So as long as the generation is successful, you can totally confident on the result that you get is correct. But then with large language model, and when it comes into application design, things have changed. And then how do you verify that? So, and then the next stage, once you build your POC, and then you want to deploy in cloud, you want it to be scalable, resilient, and secure, governed, and then you want to put it somewhere and then deploy into semi-product, or with a pre-product environment. And sometimes people may not really have that separation of these two environments, but then you may have the separation from the end user who can access that application, which means you never really build that application, making sure you work and directly put it into all your end users. Even you put in an end user, you might have a small group just test out beta feature, right? We always have that term beta. Even the model sometimes they have beta feature. So that beta feature actually we can consider as pre-product. We want to try out this application is built. Is it successful? Is it meeting our expectation? Because what we said, when we build our POC, we may use some test data. That test data may not reflect the real customer queries or the real scenario. So when you put in pre-product, you have your internal user testing or beta user, you actually can collect a lot more of the real use cases people are going to hire. But then once you use the real use cases, what if something fails? How do you know that? How do you track? How do you log? How do you tracing? All the different behaviors users do, and then put it back to further improve your application and to prepare ready for that actual production. So in the actual production, you are scaling it out. Before you could do that, how do you prepare yourself? And then if something goes wrong in your production system, what's your remediation plan? Which teams support your application? And then how do you, again, tracking, logging, monitoring the performance of your model? In traditional now, we have the model degradation, we have the model drift. There's more drift, other drifts, concept drifts. But in generative AI, drift also happens. It's just expressed in the different terms. But the fundamentally, there are not so much difference. So this is the life cycle. And you will see a different picture in our talk. They do divide it. This is what I will do for a while. So, but you can see it always starting. Whenever I said it before, the always starting as a process, and it's a circle. There's a life cycle. But then what's connecting that? The most important thing that I see that GenAI is a bit different from traditional building is this Peiyao system. In traditional application building, this is where the ML most specific part, the best practice comes in. How many of you are familiar with GenAI evaluation? Why is it needed? Because you're not just building something that can work, you need to evaluate, making sure it works successfully. It is generating the correct answer for your user or the performing the correct action. Now with Agentic, it makes this evaluation more tricky because there could be, it's not just input-output evaluation. There are two-use evaluation. There are trajectory evaluation. You have multi kind of agent architecture, whatever. It's making things more, I'll say, complicated, but also the fundamental concepts still basically have its own piece, right? But most important thing of the journey is always like not just difficult. We always say, okay, how do you map your business problems into ML problem? Now we want to say the same thing, basically. How do you map your business problem into a GenAI problem or agent? That is very important thing Because if you don't really set up the correct goal, evaluate whether the project is a valid project or not, you may just spend a lot of effort, eventually finds out that it doesn't really fit your users. I'll give you one example. This example is all the time, but it's a real example. Like if you want to build a chatbot powered by GenAI with your call center, but then the thing is like at the moment, whoever is kind of performing human response to users or thinking of the labor that you use within building, their hourly rate is very low. But then when you build a GenAI solution and then you build knowledge bases fast and it is so fancy, so advanced using the latest technology, eventually after your POC, when you evaluate in pre-prod, you notice, okay, each conversation basically costs you $2 or $3. But then if you evaluate the human that you hire from a very cheaper labor location, it's maybe just a few cents. What will the business do? Will business sponsor you changing even like using the latest technology, or we just still stick with the human? Because it's cheaper, right? But that's the most important thing. A lot of people don't even think about the ROI. So why are you doing it? So how do you map your business goal into your specific technical goal? There is a purpose that you need to think about, or even guiding your business, understand that purpose. Here's one example. Here's two examples. So this is what your business wants to achieve. Your business has this goal. I want to increase sales team productivity. Very simple. But then what does that mean? How do you map that into an evaluation goal or functional metrics and then functional metrics? So then you progressively map it into a measurable metrics where you know that is how you normally evaluate productivity of your sales. And you map it in by following the stages. This is just example, but there are other business goals. So a lot of time when we're actually talking to the business leaders or the decision makers, so they will then start challenging their product team, say, could you do this evaluation? The product team then will hesitate because they never done that. So they need to actually sit down to understand. This is also a guideline to help them to prioritize which project is the low-hanging fruit, actually maximize our ROI, and we should prioritize that. You need to be proof of why you need to do this project. And now I actually skip a lot of content, but I reserve the content that I like to do. So the evaluation framework. If any of you are doing research, or any of you actually want to do something or follow some of the good tools that you use, look at the AI. Basically, the lifecycle and also monitoring will talk about another company later. For now, like anyone heard of Organisers? Organisers? No? This is not good. Organisers is one of the most popular eval framework that was established very beginning to evaluate RAG. RAG architecture or RAG solution, retrieval augmented generation, by the way, that's RAG. Was something so popular last year. It was at the very beginning of GenAI started to be so moving, and then every company wants to build with RAG. But now no one really talks about that because they all talk about agents, even agentic RAG, you know. That's how fast this whole domain is moving, evolving. But then there are fundamentals there. Even Writer has introduced agentic eval. Anyone know other evaluation framework? Have you heard about eval? Some hope. If you not, it's good time, during Christmas time, during the break. Eventually, your skills are searching those names. Everything open. These are the foundation, and we are not really adding to it. Final. How many minutes? Okay, I'll try to accelerate. We're not really talking too much, but then thinking about there are always something that I would like to highlight. People always think we need automation, we need blah blah. But then eventually, humans are always your most trusted evaluator. 5 minutes, that'll be fast. So we'll talk about human in the loop later. So now I want to talk about observability monitoring. This is super important. If you don't really have implement monitoring or observability in your system, doesn't matter production, especially production, you're basically designed to fail. I give you a real example. One maybe not customer name, but then They have built Agentic AI in their production. We launched it for more than half a year. And then the other day we were showing them land use. I've heard about land use, which is land use is not the evaluation platforms are, it's observability. And they build the end-to-end observability for they implement land use. So you can log all the traces, information, parameter model use, and they found out in their production system, 5 features were using a wrong model than what they thought they were using. Good thing is that the wrong model was a small, which doesn't really cost them much. But then if you thought because the wrong model that they used was the more expensive, slower model, which cost them a lot. That is the business impact. And also all the past 3 to 5 or 6 months, all the development adjustment change they made in their test based on the model that they think that they were using were all wrong. The human power is the cost that is stopping the team of doing things for nothing. So that is very important, like how to think about this is more on the production system. But what are we trying to do? So another important thing I always ask my customer when I talk to them is when they have a solution, I say, how do you know the solution is working? If they don't have real-time use LLM as a job or real-time eval with any tool, it's not accurate. Who is the most accurate to give you reflecting you of the response of the LLM or your GenAI solution? You don't need it. That's why, all the AI solutions that you see today have some up, some down, although sometimes we don't use it. That's why I say, those some up, some down are the explicit feedback. Have anyone considered implicit feedback? If you think about when you're using a GenAI solution, you ask something, the model gives you a crack, then you change, you rephrase. It's an indication of your model is not doing well. You don't need some of them. Normally proactively give you, unless it's too bad, right? But all these behavioral implications can be used. How many times you use a copy, how many times you use a test, or how many times your user basically accepts the answer. Those are the metrics that actually tell you how good your models are or how bad your models are. And also the error messages, all those information, and you can give them feedback value, feedback column, and like all the information. These can be tracked into your observability platform. And after that, you need to analyze. Because if you say, oh, we're not happy with your application, sometimes it's not giving us good answers. Instead of asking your users why, each one, can give us an example. It's not a very good user experience when they need support. If you can proactively understand their pain points and giving them proactive answers or solutions, think about how good that kind of service is. Sometimes, that's why I say we put our customer obsession to our top leadership principle. It's because we always come from our customers. We think about customers. We try to give our best experience. That's the business. That's how you actually get your business revenue and then get your market share. Like there are customers, they come up, they say, oh, we like to use Database because Database is better than. That is sometimes how you win your business. Again, all of this we talked very briefly. Like I said, if you want to read more, go to that document that we published. And think about like you're building your application, what to do, right? Think about how you evaluate. Like first of all, think about is your project a valid project? Can you actually use the solution or cheaper solution to solve it rather than using LLM? Sometimes fancier doesn't mean better, right? And the second is that you know what we look at. Did you set up the correct metrics to evaluate your solution? Making sure that you know what you build is what you want or your user wants. And also, did you do proper design of understanding how your system performs? And then do you have the mechanisms identify if something goes wrong, how to fix it, which team fix it, which team is responsible for fixing it, and identifying, and do you have the alerting or do you have continuous monitoring and monitor the group and this, that, and at the end, like the continuous loop goes into change management. If something goes wrong in your production system, how do you manage the change? When you have a new model that you want to replace the old model, how do you go through the process? You need to go through the process again. Do you set up automation? Do you set up CI/CD? Do you set up anything that is needed for accelerating your solution development and deployment? And also, we haven't really talked about phase deployment. blue-green test, shell test, A/B test, blue-green deployment, kernel deployment. All of these things that you need to consider. That's why I think in one of my previous discussion, in one of classes that I was talking about this, and people saying, "Oh, it's so complicated." I said, absolutely. POC is the easiest part when you're actually doing LLM solution. But actually putting that into production, there is a big gap. So then what we have is really to help you understand what that gap might be, how to accelerate yourself into more success. Done. All right. I think that's why I say, no, I always go over to my help. Really thank you everyone, giving your time to join today's session. And thank you for coming.
Thank you, guys. I hope you liked Melanie's session. Some insights or how to run stuff in production. I think second speaker we have Binura from WSO2 is one of the sponsors. Please welcome Binura for his presentation.
Easy. Yes. OpenChoreo. So I'll quickly skip over the introductions. I work on the OpenChoreo team at WSO2. I work between architecture and product, but for the sake of completing this in 20 minutes, I'll skip over some of the pleasantries. So before I jump in and tell you the how and what of OpenChoreo, I'd like to start with the why, because I always find that it helps to talk about why we ended up building this project and why it sort of exists. So as you might all be aware, software delivery has become a very complicated problem, right? It's no longer just about writing a bit of code, pushing it out there and getting it into production. You, as developers, we now spend a lot of time juggling the 100 different tools around Kubernetes and CI/CD, your observability, just to get things moving, right? So this is something that we've realized, speaking to a lot of our existing customers, our partners, and even some of the looking at things we were doing internally, right? At the end of the day, we see a lot of organizations basically struggle to enforce these standards at scale because Kubernetes is an excellent runtime, right? It's an excellent foundation to build a runtime on top of, but it's never a platform because you end up building everything around it to make sure you can actually get your code from your Git repository to a production environment. And then something that exacerbates this problem is the highly complex tooling landscape, right? I took this screenshot again. I'm sure you've seen this in a lot of talks, the CNCF landscape. Not only do you have to pick what you want to use, you have to figure out how you're going to maintain it once you include it into your stack. You have to figure out how you're going to drive adoption internally. At the end of the day, it's a lot of cognitive load, even for your developers and for the people who actually work on these systems, it's them at the infrastructure level as well, right? It is very complicated, and what happens a lot of the time is you bring a lot of tools together and you glue them together, and over time they become this ad hoc platform that everybody starts using. So this is where the discipline of platform engineering comes in, right? So this is just a quick aside to go over this if anybody's not aware of it. So the whole idea with platform engineering is to reduce cognitive load for your developers, right? Instead of having your developers fight the underlying tooling, the infrastructure, and the behemoth that is Kubernetes, you try to build things like highways. How does a developer get from point A to point B without, going through and learning 10 different tools? So that is the premise for platform engineering. But the reality is when a lot of organizations attempt platform engineering to sort of build a platform themselves from scratch, they run into a couple of problems. The first one is, of course, there's a lot of high ongoing costs. It's never easy. You need to find an experienced team, and you need a team to start with. Building the platform takes years. I mean, if any of you have been involved in building an internal development platform at your organizations, you'll know it takes 5 to 10 times more time than you initially think, right? Because you realize a lot of the requirements as you start building and as you start driving adoption internally. So it takes years to build, it takes years to mature, it takes even more time for you to drive adoption internally, scale it out. And at the end of the day, your return on investment is very slow, right? So this is why we see a lot of internal developer platform projects sort of fail and not succeed, because a lot of people underestimate how slow the returns are. At the end of the day, everybody's trying to solve the same problem, right? You've got Kubernetes, you've got a bunch of auxiliary tooling around it. And how do I then make my developers' life easier? Everybody gets to that objective in different ways, but at a principal level, it's you're trying to solve the same problem. So this is where we thought, what if there's an open source project, an open source internal developer platform that sort of gives you all the batteries out of the box. Now, there's a difference between internal developer platforms and portals. You might have heard of Backstage, and there are some other commercial tools like Backstage out there, but they're all portals, right? You get the UI, but you end up building everything underneath. So OpenChoreo takes a fundamentally different approach. We want to be modular, but we want the platform to be ready on day one. It's not like you get all batteries out of the box, but you can swap them out with your own batteries later if you want to. So that basically brings me to this slide. You can read through the description, but what it is, it's basically an open source project. It's, everything is on GitHub. We'll get to that in a second. We're trying to build something that is modular. We understand that having batteries included out of the box will help a lot of people, but at the same time, no two enterprises are the same, right? Sometimes no two teams within one organization is the same. So we want to make sure everything is modular, and you can just plug and play the tools that you're already using and sort of bring them to a single pane of glass, so to speak. So we'll get into the architecture, right? We'll go through a couple of slides, and this will help you understand what OpenChoreo is basically structured, how it's structured, and then we'll quickly jump into a demo if time permits. So the basis of OpenChoreo is made of 4 planes. The control plane, which is like the brain of the platform. So you give it your platform intent and your developer intent. And the control plane is what basically takes care of translating your intent into actionable workloads. Now, the workloads are what gets deployed onto your Kubernetes clusters, and we call them data planes. And your deployment environments, your production, staging, pre-prod, development, whatever you call them, they all map to the data planes. And environments can be logically separated in a single data plane, or you can physically have them separated in multiple data planes. So these two, the control plane and the data plane, make the core of OpenChoreo. And the other 2 planes that you can see here, there's the build plane and the observability plane. Those are optional. You can plug in your own CI tools or your own observability tooling if you use them internally. But OpenChoreo gives you a fully complete CI/CD system and observability system out of the box. So if you look at the data plane a bit more, again, going back to the whole idea of this being highly modular, the data plane gives you a certain set of abstractions. We'll get to those abstractions again in a couple of slides, but you can add on these modules. Again, these modules are also open source. In this example, you can see the API gateway module, scale 0 module that's built on KEDA, Cilium CNI, so you can tap into deep eBPF observability data. And there's a list. And again, all these are modular, and they are open source as well. And the good thing is the whole thing is designed in a way that you can bring your own module. For example, if you wanted to use a different API gateway, you could do that. So the build plane, again, this is the optional plane. This is built on top of Argo workflows and events. It brings together a bunch of different technologies underneath, like cloud native build packs, to sort of give you days pipelines that can take code from your developers' repositories, build it, test it, scan it, and push it to a container registry and have it deployed. to the development environment on day 0. Since it's built on open source technology, you can always expand on the pipelines that are included out of the box. And then looking at the observability plane, again, it's built on a bunch of open source tooling that you might be familiar with, right? So OpenChoreo takes care of packaging all of this together, like OpenSearch and FluentBit for your logs, Prometheus, Thanos, and if you're using the Cilium CNI, Hubble for eBPF level data. So that gives you access to all your distributed logs, your telemetry data, and even things like build logs that get pushed from the build plane, right? And reback or RBAC is built into the control plane. So it makes it easier for developers to get self-service and see the logs of their components that they've deployed. And they don't have to go through a couple of systems to get there. And then the runtime is basically represented as this, as we call them cells, but they're basically a way to model domains. So when you create a project in OpenChoreo, at runtime, the project becomes a runtime boundary, so to speak. What that basically looks like is this. So we, with a project and components deployed in it, you can create uniform policies to govern how your network works within that project. For example, you can put a policy in place saying, any ingress traffic from the internet must go through an API gateway. You can put a policy in place to ensure that everything within the project is encrypted and in transit, right? So it makes it very easy to create these multi-tenant systems for your development teams, as well as sort of gives you a consistent control plane to manage things like policies. So there's a couple of ways to interact with OpenChoreo. By default, it ships with a UI. The UI is based on Backstage. There's a CLI, there's the API, and of course, there'll be an MCP as well. So one of the design goals with OpenChoreo, given we are in an AI era, is to just make everything that you do as a human accessible to an LLM or an agent. So these are like the main ways to interact with the system. Again, just a quick aside, I mentioned earlier that the build system or the build plane is optional. So if you look at this example, we are basically bringing GitHub Actions as a CI system instead of, OpenChoreo's built-in build plane. Because the UI is powered by Backstage, you can install the GitHub Actions plugin for Backstage, and that will give you visibility into GitHub Actions. You set one up to build, test, do whatever you do with your containers, and then you can invoke an API on the OpenChoreo API, and that will update the deployment to the OpenChoreo data plane. This is just a very high-level example, but just to drive the point home. So there's a lot going on with OpenChoreo, but this is one thing I do want to show you is the whole idea of creating abstractions. So we talk about reducing cognitive overload on development teams, right? And one of the ways you can do that is by simplifying things. And the way you simplify things is by creating abstractions. And again, creating abstractions is a tricky business. It's very hard to trip yourself up and miss the abstraction and just end up with a leaky abstraction. But with OpenChoreo, we try to make it much easier for platform teams to create abstractions for their development teams. Now, if you take a look at this slide here, we are trying to create a HTTP service component. It's a very common composition, right? You have your Kubernetes deployment, you've got a service, and if you're using the Gateway API, you'll have HTTP route. What you need to expose to your developers is a more simple abstraction. For an example, they know what the port is, they want to know, they can decide if it gets exposed or not, and the number of replicas. Replicas is a bit contrived, but for the sake of the example, we'll leave it there. This is how you define a component type in OpenChoreo. I hope you can see the text, but all of this is on the GitHub project if you want to have a look at it. So when you create a component type, you define the schema, right? So those are the inputs for the developer. So there's a type system here. There you can apply validation rules and also default values. So the schema that you expose, the simplified abstraction that you expose to the developer is strongly typed, validated. So your developers aren't just writing random YAMLs. And then if you look at the resources section underneath, that basically explains what this component type emits when you create an instance of it. So you've got your deployment, your service, and your HTTP route. And the templating language that we picked is called Cell, Common Expression Language. It's very easy to sort of look at this and understand what's happening for anybody who's familiar with Kubernetes YAMLs. It's a very simple syntax when you compare it to some other alternatives out there. And then once you create the component type, your developers can just use a component. As you can see, strongly typed, validated, and they don't have to deal with all the intrinsic stuff that is hidden behind the component type, right? Now, again, this is a very simplified example, but you get the idea. Now, if you're wondering, okay, how do I patch things in different environments? Do I need customize? The answer is no. So OpenChoreo sort of brings together a lot of concepts, and components are environment aware. So basically, in this example here, I've expanded on it a bit more. As you can see, you can define custom types, again, using that simple notation of using a type, some validation rules and defaults. And then you can specify your environment level overrides, right? So what that means is you can create an abstraction for your developers, component, and then you can also create environment-specific overrides, so you don't have to use things like customize and very complicated GitOps pipelines to manage multi-environment promotions. So just to tie everything together, OpenChoreo has two distinct personas for like the different users. There's platform engineers and your developers, right? So platform engineers define component types and traits. Again, all of this information there is in the GitHub project, but in 20 minutes, we won't get far. So developers use those abstractions, and then on the other side of the screen, you'll see releases and release bindings. There's a few more abstractions that enable you to do GitOps without bringing in complicated tooling and pipelines and scripting things yourself. And OpenChoreo, I may have forgotten to mention, is completely declarative. All right, I've got 4 minutes. And yeah, it gives you a lot of other abstractions, sort of build out your entire infrastructure on top of Kubernetes. But again, there is no way we'll get to that within this time frame. So what I'll quickly show you is how you can get started with OpenChoreo. So you just go to openchoreo.dev, click on the quick start. What I'll do is I'll just show you the dev container. So, oops. Colima instances. Code is already allocated. I think I have this running in the background. All right. Unfortunately, I don't think I have time to debug this demo, but this is fairly straightforward. Have a look at the documentation. It'll take 2 minutes and you will have it up and running, and you can deploy a demo. For example, we've got a couple of easy demos. You might have seen the GCP microservices demo that deploys like 11 different applications. So there's a demo for that, just 2 minutes and you'll get that running. Again, have a look at the documentation. It goes through all the stuff that we talked about in depth. And yeah, there's a lot to go over, but for today. I hope this works. And the UI is coming in the next release. We are currently at 0.4. So 0.5 will be around December, and we are hoping to ship the Backstage UI and a lot of other things that are in the roadmap. Yeah, you can try it out. You can tell anyone in your team that might be interested in this project. If you want to get involved, it's all on GitHub. There's a Discord server as well. Just let us know, or drop a message and give us a star. We've been able to get some traction on GitHub. There's a lot of interest. Yeah, so if you'd like to get involved, please do. And yeah, that's about it. Thanks for listening in.
Thank you, Binura. Guys, if you have any questions, feel free to ask, or maybe do the session. We have our third presenter, Vincent. He's from AWS. He's the same thing in mind, and then he's talking about open source AI agents. So please give him a moment.
Thank you. Do I need to connect this or just
share the
demonstrate? Yes. Yeah. Okay. Okay. Thank you, Professor. Hey, good evening, guys. My name is Vincent. I'm the AI Strategist at in AWS. Today, I want to talk something about Agentic AI. That's a very popular topic recently. So, why we have the Agentic AI? I'm sure that there are many reasons for that. But one of it is that the function models recently we get it is smarter and smarter. So for example, what we heard recently, Grok 4.1, GPT 4.1, or Generative. So they really have a good ability to run the deep thinking, to finish the complex workflow on behalf of humans. So that's a very important reason why the Agentic AI is written, because we are hoping to leveraging the foundation models to help us finish some complex jobs, make it automatically run the task by themselves. So let's see some evolutions of the Agentic AI. So in the beginning, it start with the AI assistant. Make it easy, like a chatbot, right? You ask the agent something and it gave you the feedback, gave you the answers. And then we want it to handle more complex stuff, like we ask it to run a single job, but they need to finish by themselves automatically. So that is the way we run some Generative AI agent. And after that, with more and more smarter foundation models come out, and we build more complex agent AI system. We leverage the function model to build a more complex system involving the multi-agent system, and ask it to mimic the human's logic and human's rhythm to help us to finish some complex workflow and jobs. But there are some without laws about agent AI, because if you want to build an agent AI, you need to follow some principle or follow some rules. Because we don't have too much time, so I don't want to talk it one by one, and you are welcome to it offline. But one thing I want to talk about is like, what is the first step when you build an agent AI system? I think it could be the third law. Like you need to decide when to create or build agentic AI. and when not to build the Agentic AI. Because sometimes just use applying old code can resolve the problem, which could be better than the AI agent. For example, let me ask you some scenarios. Like right now you have a front-end system. That front-end system will accept requests from your end user. And to authenticate the user if he has the permission to execute some tools. Would you need to build an AI agent with some complex tools to finish the job? So the answer is you don't have to do that because you can already use the Python code, use the browser code, whatever your old code to finish the job. You don't need to introduce another layer. You don't need to introduce another AI agent to give to instead you to finish the job. Because in that way, you will introduce latency. You will introduce cost. You will introduce the hallucination by the large language model. And the second scenario